Hello and welcome back. In today's little episode, I wanted to discuss why the quadratic formula is this thing here. In GCSE, we don't tend to talk about why it's the case. We just talk about this is the quadratic formula. If you see a quadratic of this format, substitute the a, b, and c into here, and you'll get the solutions for x. Before I actually go through the proof, I wanted to do a quick example showing how it works with where I've used a, b, and c as some numbers, just to see how the machinery works. So I'll just start off with a quick example. Let's have, I'm not going to substitute this into here, but rather what I'll do is I'll use the method that we're going to use to go from there to there. I'm going to use the same method on this thing here. What I'm going to use is the method called completing the square. When I complete the square on this thing here, I get x plus 3 all squared. And the reason I'm always going to get a half of this number there is because, well, if I take this x plus 3 to the side, if I just take this over here and I expand it, I'm always going to get double of this thing here as a coefficient for the x term. So I'm going to get x squared plus 6x plus 9. But if I look back here, I don't really want this to be a plus 9. I want it to be a minus 8. So really, this bit here gives me the first two for free. It gives me the x squared and the 6x, but it also gives me a plus 9, which I don't really want. And notice that this 9 came from the fact that it's just 3 squared. So I'm going to subtract this 3 squared, or the 9. And then I'm also going to take away the plus 8, because that's still there. I haven't done anything with that. And that's going to now be equal to 0. And notice that this thing here, this guy, is exactly the same thing as this guy here. X plus 3 all squared was x squared plus 6x plus 9. I take away the 9, and now this bit is exactly equal to that bit there, and then I just take away another 8. What I'm going to do next is just collect. So I have x plus 3 all squared minus 17 equals 0. Then I'm going to continue on by adding 17 to both sides, square root, take away, etc., etc., and you'll end up with the solution. I'm not going to bother doing the rest of it. I do want to jump into the proof now. So if we start off with ax squared plus bx plus c, we need to start with this. We're going to end up with that bit at the top there. A different colour pen, because I can. Right, first thing I'm going to do is, well, notice that the a can't be a 0. If a was equal to 0, then I wouldn't actually have a quadratic. I'd have bx plus c equals 0, and that's a linear equation. It's no longer a quadratic. So I need to make sure, for this to be a quadratic, a cannot be equal to 0. And that tells me then that I'm allowed to divide through by a. If I divide through the whole thing by a, I end up with x squared plus b over a, x plus c over a equals 0. Right. Next thing I'm going to do is try and use that method of completing the square. And I remember that I need to halve this. So I'm going to have x plus b over, you guessed it, 2a. Now this is where it starts to get a little bit complicated, because now I need to see what on earth does that actually give me. So let's just take that to the side, expand it, see what it gets. See what it gets for me. X squared plus, well, I'm going to get b over 2a multiplied by x, so that's going to be b over 2a. But because this is a square, I'm going to have, in the other bracket, I'll also have a b over 2a, which I multiply by this x. The b over 2a in the first bracket is going to multiply by the x in the second bracket, and the b over 2a in the second bracket is going to multiply by the x in the first bracket. And when you do that, you'll notice that you are indeed just going to end up with a b over a, because a half of b over a plus another half of b over a makes a full b over a. But also then I'm going to get over here, when I square that bit, I'm going to get b over 2a squared. I'm going to get that. All right. Now, remember previously, we know that this bit here, these three terms, they're going to give me exactly x squared plus b over ax. But I'm going to get this extra term here, which I don't really want. But I do want a c over a. I want to add that on somehow to this thing here. I want to get rid of that, because that's extra. I don't really want it. So I'm going to take away b over 2a all squared. So far, this bit here gets me exactly these first two terms. So I need to add on a c over a now to make it exact. So now this here is exactly the same as this bit here. And now that it's just going to be equal to 0. All right, so I'm just going to put a little box around this. It's kind of getting in my way. We're going to continue this down here. Right. So now I'm not going to expand that. I'm not going to expand that because that would be a bad idea. But I am going to try and simplify this right hand side a little bit. Okay, I've got just one x now, which is good. That's what I'd like when I'm solving equations. I'd rather get just one occurrence of the x, which I've sort of halfway there. Let's continue though. So I'm going to leave that x plus b over 2a there. Let's try and simplify this up a little bit. What can I do? Well, let's just expand that. I'm just going to take all of this stuff to the other side. So I get x plus b over 2a equals b squared over 4a squared minus c over a. Okay, this side I'm just going to ignore that for a minute, but I'm going to do a bit of work here. I want the denominators to be exactly the same, so I'm going to times this at the top and the bottom by a 4a, so I get b squared over 4a squared minus 4ac over 4a squared. Notice that here I've just multiplied this term by at the top and the bottom by a 4a. Right, so far we've got this. Right, so at this point hopefully things are starting to look quite familiar. B squared minus 4ac, 2a, etc. Next thing I'm going to do is put this over one denominator. So b squared minus 4ac over 4a squared. And of course I want to isolate the x. So I'm going to try and get rid of the square, the b over 2a, etc. So I end up with just the x. So I'm going to square root now, both sides. By square root, remember you're going to get two solutions, so you have to have the plus or minus there. The square root, I can bring it inside. I can square root so the top bit and the bottom bit separately, so I'll have plus or minus square root of the top bit, square root of the bottom bit. Well, square root of 4 is 2. Square root of a squared is just an a. The square root and the square cancel. And now we're pretty much finished. All I'm going to do is get rid of this b over 2a, take it to the other side. I'm going to stick it right here. I get x equals, I'm going to take away, so minus b over 2a plus or minus square root of b squared minus 4ac over 2a. And of course stick that again, just as we did at the top there. Just to neaten it up, put it over one denominator, so it's going to be minus b plus or minus square root of b squared minus 4ac over 2a. And that is the proof for the quadratic formula. Thank you very much for listening. Hope you enjoyed it.